All right, so this one, same exact drill, second step, slow step. So we write it's gonna, now mathematically it's gonna get a little weird in a moment, but we'll deal with it. All right, so second step, slow step. Okay, concentration B, concentration D. Is everybody all right with that piece? Everybody can look at one step and go, okay, that's the rate law for that step. Good. If it's the second step, though, we have to address the fact that this, again, notice B is an intermediate. B was created, and now it's destroyed. So we need to take into account that thing and get it out of there. So what we're going to do is look at the first step. I'm going to write it out this one more time, but then I'll show you the quick way. Rate forward equals rate reverse. All right, so the rate forward is concentration of A, the quantity squared, times K. The rate reverse, concentration K times the concentration of B, concentration of C. Good? Okay. Solving for B gets just a slightly bit weirder mathematically because we take and keep B by itself. Everything else goes to the other side. We'll call that K1. K over K1 equals concentration of A, the quantity squared, over concentration of C. Good? No mathematical magic, right? All this is they're doing the same thing, saying that's the rate for the going this way. All this is, that's the rate going that way. All I did in the green, algebra. Right? Algebra 1. Okay? Last piece. Now what we're going to do, we're going to get a new color, just be like that. We're going to substitute this into that. So we're going to carry over rate equals K. Now we're going to grab all of that, bring it in here. Some other K, concentration of A, quantity squared, concentration of C. All that goes where B was, concentration of D. Okay, no magic. I just took this and put it where B was. That's all I did. Okay, the last step, just to make it look right, a constant times a constant over a constant is still a constant. And so it's going to be concentration of A squared, concentration of D, over concentration of C. Again, blue step's just algebra. Okay. Now, what does that mean? What does that mean? That means if I put in more D, it's going to make the rate go faster. Because if this goes up, that goes up. And they're proportional, so if I double D, I'm going to double the rate. True? Don't go there. All right? Now, here's the trick. If I double A, it has a squared effect. So if I double A, the rate is going to be 4 times as much. It's going to quadruple. If I triple A, it's going to be 9 times as much. You see that? That's just algebra. Now here's what's weird. If I add in more C, it's going to slow the rate down. Okay? By putting in the product of the first reaction, it's actually going to slow the rate down. Do you see that? Okay? That's what the rate law is. So that all you have to do with these. Now, somebody asked in one of the things, they said, well, how are we going to know which one's the slow step? You look for what's involved in the rate law. If I just said the rate is A squared, you know the first one's the slow step. But having all this complex stuff, I know that the first step's not the slow step, so the second step must be the slow step. See it? Because if it were just the first step, if this were reversed and that was the slow step, it'd just be A squared, because the rate law would be strictly based on the slow step. Kind of make sense? Keep messing.